Hi, kids. All right. One more problem. I have an incline, so we'll do another practice a little bit with incline. I have two masses. They're connected by strings. There is a string connected to the wall. My masses are not moving, and I want to find the tension here and the tension there. Okay? So, guess where I'm going to start? That's right, a free body diagram. So let's do that first. Again, I'm going to draw them two different colors to keep track of them so that I don't make a mistake with this. So M1, I'll use my lovely magenta. So here is, okay, M1. And then I want to draw the forces acting on M1. So let me, okay. So again, if I draw forces acting on it, FG goes straight down, okay. Normal force this way. And then my tension goes that way, okay? Again, I want forces that are only parallel or perpendicular. So again, this is going to be my X, this would be my Y. So I need to break FG down into its components. So I'm going to have, okay, FG, this would be FGX. And then this side would be FGY. Now again, check your picture here, guys. Make sure that FGY is perpendicular to the incline. If it's not, fix it. Make sure that FGX is parallel to the incline. If it's not, fix it. Okay? And then my 30 degrees, remember, it goes in that top angle right there. So this was 30 degrees, so this top angle here. I know it's hard to see, but I wrote 30 right there. Okay? So that's 30 degrees. If I do M2, okay. I get FG here. Okay, so now I have two different strings. So I'm going to call this actually string 1 and string 2, so that this would actually be FT2. Okay, and then, so this one here is FT2, and this would be FT1. So that's why I do have to make sure that they're different. I'm going to break my FG into its components again. So FGY goes perpendicular, and then FGX goes parallel. Okay, and again, 30 degrees in that top one right there. All right, normally I'd have to write two different equations, one for the y, one for the x, but here I don't have to worry about the y stuff, okay, because there's no friction, I don't need to know Fn, so really all I have to do here is solve for my my x one, which is the parallel stuff. So I'm going to do that. For M2, if I add up my parallel forces, so the sum of all the x forces, I'm going to go FT2 minus FGX equals 0 because it's not moving, it's stationary. If I do the same for this one, now this one's a little more fun because there's one more variable there, one more force. Okay. For this one, I am going to get FT1 minus FT2 minus FGX, and that equals 0. Okay, so again, the hard part, free body diagram, equation, free body diagram, equation. Okay, now it's just a matter of plugging in some numbers. So if I do this here, I'm going to get FT2 minus M1, so M1 is 20, so 20 times 9.8 times, that's going to be the sine of 30, okay, equals 0. So that means I can solve for FT2. 196 divided by 2 is 98. I believe I did that in my head, so 196 divided by 2, yep, 98. So I get 98 newtons here. So that is my answer for one of them. Now, if I know FT2, I can then plug that in here. So then I get FT1 minus 98 Okay, minus the other one is going to be 40 times 9.8 times the sine of 30 equals 0. So 392 divided by 2 is 196. Duh. I don't know why I had to do that in my head. But if I go, so I'm going to end up with ft1 minus 98 minus 196 equals 0. So I get ft1 equals, so let me add 98 to that, and you get 294. And there you go. Okay. Bye, kids.